Okay, so my name is Maxwell Mallow, and this is my math autobiography. Just to give a brief autobiography about my math experience, obviously in elementary school as well as high school, I went through the math curriculum. I went all the way through grade 12. I was in the applied strand in high school, so I think what we saw was we didn't see much calculus. And then when I got into college, I went to environmental science, which dealt with more practical uses of math in relation to science, especially wastewater water treatment plants, and chemistry as well. But wastewater water treatment plants involved flow rates per different chemicals or water, and how it relates to how the system would work. So it was kind of a math in relation to science. Well, when I got into university, I took environmental studies, which we had environmental economics class that had functions into it. I was not great at that, kind of new to calculus and functions, and it's luckily I was able to pass the class, but it was definitely not a strong suit. And then in the workforce, I worked in forestry, and I also worked in applied sciences. And forestry is just a lot of basic accounting with inventory, but at maybe a very large scale. And then for applied sciences, it was I worked as a chemical operator, and we had to understand flow rates and discharge rates and volumes and how it relates to chemical processes, and obviously how it distributes the product and kind of forms the product, certain pressures, temperatures, and chemical pressures, temperatures, chemical composition would formulate a different product, so we had to be knowledgeable about that. Anyways, in relation to week one, the week one articles, for the first lesson, I found it really interesting. The first article, the TIMSS videotape study. I found it really interesting about the Japanese curriculum and how it kind of excelled due to its very due to being, I guess, more it prepared students to be more mathematicians and kind of think of things from a holistic point, and be able to use critical thinking and problem solving to attack a problem instead of instead of kind of having that barrier between teacher and student where it was just a yes no answer, and then kind of kind of like a closed door, versus like the Japanese, it seemed like a very much open door, and a lot of dialogue, a lot of communication between students and teachers about the problem, which allowed for more thinking in different ways. And I think that's really beneficial. That's very beneficial for students. I wish I had that. I remember in elementary school, we used to get it was mental math. We used to do it was 60 questions in 60 minutes, and you try to answer as many questions as possible. And it was just it was basic memorization, which I think is important, but I think it defeats the purpose of trying to develop a problem-solving mindset towards mathematical equations, instead of just a memorization tactic to memorize like timetables. Or it's hard for such an abstract subject that math is. It can't just be memorization. There needs to be abstract solutions to incorporate it. I found it really interesting, and I think it was a great case study to read, and definitely inspiring into what I want to be as a teacher. So that's my autobiography, and that's my reflection for the week one the week one content. And thank you, and see you next week.